hydraulic and pneumatic system. So first of all, we should know the basic concepts behind the hydraulic as well as pneumatic system. So Boyle's law as well as Charles' law is the basic pneumatic as well as hydraulic system. First of all, we say about Boyle's law. The volume of the gas will change inversely with absolute pressure of the gas if the temperature of a given amount of gas is held constant. This volume is inversely proportional to pressure. That is, volume is proportional to that is equal to 1 by P. So that is mentioned here. V1 is equal to P2. So V2 to P1. So this is the thing where pressure keep it in constant, temperature constant. In Boyle's law, that is in Charles' law, the volume of the gas will change directly proportional to absolute temperature of the pressure, and the given amount of gas is held constant. So that is V is directly proportional to temperature. So this is the thing where constant, we keep it pressure as constant this process. That is Charles' law. So next, gas-Dirac law. The pressure exerted by the gas is directly proportional to absolute temperature if the volume of a gas is held constant. So where constant volume process takes place here. Then general gas law, Boyle's law, Charles' law and Dirac law can be combined into a single general gas law as defined by P1 V1 by T1 is equal to P2 V2 divided by T2. So compressor. A compressor is a machine that compresses air or gas from low inlet pressure, that is atmospheric pressure, to high desired pressure. This can be accomplished by reducing the volume of gas, generally positive displacement, reciprocating piston pump, rotary screw pump, and a rotary vane type are its classification. So first, see the piston type reciprocating compressor. Most commonly used type and operating principle is similar to IC engine. It consists of cylinder, cylinder head, piston, piston rings, inlet and exhaust valves, crank, crankshaft, containment rod, etc. A prime mover, generally motor, is used to run the compressor. The rotary motion to the crankshaft is converted to reciprocating motion of a piston through a crank and connecting rod. During downward stroke, the pressure inside the cylinder falls below atmospheric pressure due to the pressure difference, and the inlet valve is opened. As the piston moves upwards, the inlet valve gets closed and the pressure increase makes the exhaust valve to open and deliver the air to the outlet. Multi-stage air compressor. If the compression of air from initial to final pressure is carried out in more than one cylinder, then the compressor is known as multi-stage compressor. If a single stage compressor can give compressed pressure air of about 5 bar only, the compressed air temperature can increase to 200 degrees Celsius, which in turn increases the power required to drive the compressor. Thus, effective cooling is needed. When multi-stage compressors are used, it reduces the input power requirements and increases the efficiency of the compressor. Staging. Staging is dividing the total pressure among two or more cylinders by allowing the outlet from one cylinder into the inlet of the next cylinder and so on. So similar to screw pump, compression is accomplished by rolling the trapped air into the progressively smaller volume as the screw rotates. The rotors turn freely with controlled clearance between both rotors and the housing. A precisely measured amount of filtered and cooled air is injected into the compression chamber, mixing with the air as it compressed. Single stage compressors are available with capacities 1450 CFM and pressures of 120 psi. In this, a cylindrical slotted rotors turn inside of a stationary outer casing. Each rotor slot contains a rectangular vane which slides in and out of its slab due to the centrifugal force. As the rotor turns, air is trapped and compressed between the vanes and then discharged through a port to a receiver. Vane compressor can operate up to approximate 50 psi in single stage and 150 psi in two stage designs. Air filter. The function of air filter is to remove contaminants from the air before it reaches the pneumatic components such as valves and actuators. It can filter particles in the range of 5 micron to 50 micron. The air entering the filter swirls around due to deflector cone. The centrifugal action causes large contaminants and water vapor to be flung out, which gets collected at the bottom. A baffle light is provided to prevent the turbulent air from splashing the water into the filter cartridge. At the bottom of the filter bowl, there is a drain plug which can be opened manually to drain off the settled water and solid particles. Lubricator. A lubricator ensures proper lubrication of internal moving parts. The compressed air enters the lubricator. Its velocity increases due to pressure difference between upper and lower chamber. Due to low pressure in the upper chamber, the oil pushed into the upper chamber from the oil reservoir through the siphon tube with check valve. The main function of valve is to control the amount of oil passing through it. The oil drops inside the throttle zone where the velocity of air is high, and this high velocity air breaks the oil drops into particles, that is small particles. There is a mist of air oil is generated. It is difficult to hold an oil mixed air in the air receiver as oil may settle down. Thus, air is lubricating during secondary air treatment process. Low viscosity oil. Air pressure regulator. A function of the air pressure regulator is to regulate the pressure of the incoming compressed air. It consists of diaphragm, valve, main and dampering springs. The diaphragm allows the proper amount of movement for opening and closing at the valve seat when the adjusting screw is in the fully retracted position. The valve is closed. When adjusting screw is turned to compress the adjusting and dampening springs, the valve is opened and allows air from the inlet to outlet port. The pressure of outlet air depends upon the size of the valve opening that is maintained, which can be determined by compression of the adjustable spring. Vent hole is provided to let out the undesirable waves to the out.